Hello everyone, my name is Anna Nisvijevskaya and I'm pleased to present our work on AI documentation using the Databook framework, tested this year as an audit supporting device on a fraud detection model called AlFraud. This study is a collaborative effort with Simon Lemoilic from Quinten Finance, a leading French data science company. As we can see in many sessions here, algorithm transparency is a critical issue in the European Union. This transparency is needed to ensure efficient decision-making through AI applications and also trust in innovation, which can be accelerated through knowledge capitalization. This collective learning simplifies the data reuse, should it be data recognized as useful or not at the end of an exploration phase. This AI transparency is especially required with regulations such as GDPR or the AI Act and apply to external algorithms, in particular foreign algorithms, but also to models created internally by European organizations. These need for auditability have been translated into AI documentation requirement for the most risky AI usages. And what a chance for us, because we have been working on AI documentation for the last 9 years of data science projects in French companies. We have shown that documentation can be an effective tool for human data mediation, facilitating coordination among stakeholders with diverse interests and skills. It also helps in creating a project memory essential for capitalizing on business knowledge and managing data project portfolios. To address these challenges, we developed a dynamic documentation framework called Databook, but it has not been tested in audit context until this year. Indeed, the first proposals in this area only began to emerge after 2022, whether through academic literature, offers from international editors, or public authority guidelines. So, what is concretely a Databook framework? A Databook is an AI documentation framework based on algorithm metadata generated during a data science project. These projects are design processes usually carried out through the cross-industry standard process model for data mining, called CRISP-DM model. It is organized around 6 activities, and each one is linked to specific data objects. These data objects are business concepts translated into source data, which is organized into a specific structure that feeds one or several models that are characterized by statistical results. These results are then translated into functional or business results, and if they are judged good enough, the complete AI model is encapsulated into a usage, such as an application, and deployed for exploitation. Most of the time, these projects are exploratory and generate data and knowledge that will not be directly deployed. It is important to capitalize on these too and reuse it later. Finally, AI design projects generate usual project information non-specific to algorithms. The past research shows that these 6 standard activities result in data objects themselves, composing the final algorithm, but also a wide range of metadata on each data object. This metadata is usually ignored by AI community and research. Moreover, this metadata is very heterogeneous, as the algorithm application design is usually a co-design. It results from a convergence of data, business, regulatory, technical, and other activities realized by several skill holders. When we combine methodically this metadata, we can decide if we select or exclude each data object from the final algorithm. This decision is itself a new metadata, translating the status of a data object resulting from the collective convergence. Let's see how the convergence works. Imagine that we work on a fraud detection algorithm and hesitate to include some data. For example, the email domain. Our data protection officer says initially that it is not a personal data, so we can use it. Our data engineer confirms that the data object email is consistent and creates a new data object that he calls email domain in our brand new dictionary. The machine learner tests this pattern and confirms that its impact is very interesting in one of the models. In parallel, our business analyst makes a short basis analysis and is afraid that this variable is correlated to unemployment and to the age of the client. At the end, we decide to exclude this variable. This is multi-skilled convergence. Usually, it is oral in small projects and totally non-documented. So the next time we create a tarification model, for example, we will lose our time to do the same job on the same metadata, unless we use the Databook framework. With the Databook, the metadata is generated throughout the project on each data object. Here we can see how a structured format compatible with simple Excel files can be presented, for example, for source data or for a model evaluation. At the end, if we select all the data objects with the status selected or included, we obtain the structure of the final deployed algorithm. In theory, this was considered sufficient for a possible audit, but this year a real-world audit took place. We observed an audit of a fraud detection model in a French bank. The AI model have been documented through the Databook framework adapted for operational needs and combined with usual audit and documentation methods such as text reports. The audit method was based on a self-assessment guide provided by the CNIL, which is the French Data Protection Authority. The self-assessment guide is structured into 199 questions on 7 themes, covering the requirements of the AI Act. The audit was realized by the bank DPO, Data Protection Officer, through 5 workshops with the project team members. The audit, very rich and complete, was a typical declarative exercise which did not need the manipulation of the algorithm itself. AI documentation was largely sufficient. This empirical action research drives 4 conclusions. Firstly, good news for us, the AI model conceived through the Databook documentation framework is judged auditable and meets the regulatory requirements. Secondly, we qualify 50% of the audit questions as requiring algorithm metadata. This observation confirms the pertinence of the framework, but also points out that it has to be completed. This is confirmed through the observation of the enlargement of the documentation realized on the field with textual formats which eases the mutual understanding, and also the addition of several quite usual audit documents, not specific to algorithms, such as risk matrices and the RACI matrices. This leads us to propose an audit extension of our Databook framework. The audit extension is a minimalist documentation in formats such as text reports, including metadata in the form of tables or lists. It can be used for all data models, including AI or data models subject to regulatory constraints. It includes 4 types of documents: the project documentation, the data model documentation, the usage documentation, and the knowledge documentation. We associate to each type of document the underlying metadata slightly adjusted in order to include specific regulatory requirements and non-specific audit documents. For example, these can be used to both explain and describe algorithm choices, the description being presented here in the form of a list of optimized hyperparameters of the final model. It can also be used to store more massive metadata such as data dictionaries or learning set technical description in structured metadata formats. Finally, it can help the documentation of questions which do not require metadata, for example, the description of the maintenance procedures, which can themselves include illustrations. In general, this approach suits usual audit practices as far as they do not require the computer code to be manipulated. For example, by relying solely on the documentation, exchanges with the experts, with the contributors, or visual analysis of the data objects composing the algorithm. Its specificity is simply the alignment with the standard data science processes. Our AI documentation proposal thus addresses the major issues of algorithm transparency, such as the reusability of metadata and algorithms, efficiency of use in the field, adaptability to a wide range of use cases, and the ability to stimulate cooperation. The audit extension, in particular, respects business practices, better adapts to new requirements, and addresses the ergonomic limitations linked to basic Excel formats, which have been identified in the past work as limitative. However, these results are still limited by our field. In fact, we have only one real-world case study in only one company, which is Quinten, marked by specific cultural and business and skills organizations. Finally, we need to pursue our efforts to facilitate the ex-post AI documentation, as the design of such metadata documentation remains time-consuming when it is not natively generated. So we plan to confirm the framework's usability in a wider range of contexts, and actually a large language model project is currently underway to test it, and to confirm that the most widely used project management methods are compatible with this documentation process. We will then stabilize this minimal documentary structure and develop it into a more interoperable and optimized format compatible with ex-post documentation. And finally, we will contribute to the sharing of such work and practices for more transparency and collective confidence in artificial intelligence. Thank you for your attention, and for further details or questions, please feel free to contact us.